Now, so just we said that you have to project this charge with a certain velocity. There are different cases for this case. Now, if I'm just going to project it with a velocity v, and this velocity is perpendicular to b bar. So under that condition, I can write it down this f, which is q v bar cross b bar. Again, you can just write it down, that is vb sine theta. So for this case, your theta is equals to 90 degree. Then I can say that, so this f has to be qvb. So this is the maximum force that is experienced by this charge when you project it exactly at perpendicular to the magnetic field. Again, since the direction for your velocity and the force, it is perpendicular, so there is no work done in this case. Yeah, we are saying that work done is equals to force into displacement. So that means the force and displacement should be in the same direction, but since for this case it is perpendicular for this case, so the work done is always 0. And then you can prove also the kinetic energy is also going to remain same. It is not going to change when it just moves along this circumference of the circle, or you can say it is performing that circular path over here. So that is what you can say for this first case, where you are just going to project it that perpendicularly. The next case, so if I say that this v bar is making some angle phi with your b bar, so definitely again I can say that, so you have to now project it with a certain angle phi with the b bar. So let's say this is nothing but the velocity v, again this is nothing but your b. Fine. So under this condition also, now this f is equals to q into v bar cross b bar. You can write it down, this is your vb, obviously that is a sine theta. So this is nothing but the one component that you can write it down. Fine. And again, so definitely it is having two components. One is this, that is a v cos phi, and this is nothing but v sine phi. So this v sine phi is responsible for your that force, and because of which you can say that it goes on in the circular loop or that circular path, and at the same time this v cos phi will just provide it some momentum in the forward direction. It provides some velocity because of which it is moving in this horizontal direction also. So that is how you can say that. So it is performing that your both the motions, so it is performing that circular as well as it is moving in the forward direction also. So this is about when you just throw that, or you can say that when you project that charge with a certain angle phi, so that is how it is going to move, or it is going to perform that your helical path situation.